Nagaraju, Department of Computer Science and Engineering, YSR Engineering College of Yogavamana University, Prothutur. I was the first batch student of JNTU Anantapur, 89 to 93. So today I am going to discuss about code optimization. So that is today's contents are introduction to code optimization, optimization techniques, gate problems and solutions. So introduction to code optimization. Code optimization is the fifth phase in compiler design. Code optimization is the fifth phase in the compiler design. So it is an optional phase, but nowadays it is a more important phase in the compilers. So it rearranges the tree generated by parser such that to consume fewer resources or to produce more speed. The main objective of this code optimization is it rearranges the tree generated by parser such that to consume fewer resources and to produce more speed. So that is the main optimality principle of the computer science is you have to reduce the storage space and you have to increase the execution speed and you have to use a minimum number of resources for execution of any program. So that is these three are optimal principles of computer science and engineering. So one is the optimal resources utilization and increasing the execution speed of the program, and the third one is reduce memory space, that is the storage space, or next time complexity, space complexity and the minimum number of resources. So for this purpose the code optimization technique is very useful. So that is how it will so that is optimize the code. So the meaning of the code is not altered. The meaning of the code should not be altered without altering the program meaning. So it will be reduce the number of instructions. So at the end of the session, I will explain one program how it will be reduced, right? So it increases the execution speed of the program. It increases the execution speed of the program and it reduces the storage space. It reduces the storage space. So optimization can be categorized into two types. So one is the mission dependent code optimization and another one is mission independent code optimization. So what do you mean by mission dependent optimization? What is a mission dependent optimization? It has special mission properties that can reduce the amount of code or increases the execution speed. It increases the execution speed. That is a mission dependent code optimization. That means here is, so that is the user need not to, so that is a concentrate on, so that is the code optimization. So but you use it depending upon the depending upon the architecture or depending upon the type of the computer, type of operating system or type, so that is here is, so the execution speed will be increasing. So for example, nowadays you see that, so suppose when you are using the Core i7 processor, so its speed is better than Core i5 processors. So but when you are taking the parallel computers or supercomputers, so the definitely speed will be increasing. So that's why here is, so we can use the, so suppose if you are using the latest computers, definitely the execution speed will be increased as well as it compacts the entire code. So for example, so in the mission dependent, exactly what you have to do. So first one is the register allocation. So that is the register allocation. So generally there are 8 types of registers are there. So but allocation of registers also increasing the execution speed. So for example, so suppose in the C programming, in any programming, if you want to repeat the process, so then we are using index variable. So suppose, so for I is equal to 0, I is less than 10,000 times I plus plus. But here is, so when you store the I value in the memory, it will take more time. Or if you are storing that value, if you are declaring that integer as a register, so then it will increase the execution speed. Or register allocation means, suppose there are different types of three code addressing already we have studied, right? So triples or suppose quadruples or something like this. But when you are using that, the proper utilization of the mission also increase the code optimization things. So another one is the mission independent code optimization. Another one is the mission independent code optimization. So that is in the mission dependent, only hardware engineers can take care about. So that is how to optimize the code. But in the mission the independent optimization, so it depends only on the algorithms or arithmetic operations in the language. So that is, it depends only on the algorithms, arithmetic operations in the language, but not on the target mission. So that means here the mission independent only depends on algorithms. That means what programs we are writing, and arithmetic operations, what operations we are using. So based on that, here is the user can reduce the program size, right? So suppose while you are writing the code optimization, so that is, here is the first we are taking source program, and the source program will send to the front end. So already I explained the lexical analysis, syntactic analysis, semantic analysis comes under the front end. So in the, already we have studied that semantic analysis. So in that cases, during this front end, how the code will be optimized. That is, user can do profile programs, so change algorithms and transform the loops. So that means here is in the front end, of the compiler. So generally we'll concentrate on user can do profile programs and change algorithms. Suppose, so there are different algorithms may be available. For example, so suppose when we are taking the GCD of two numbers, so then we can write more than 10 ways the same program. So I will show that. So that is the 10. So that is out of the 10 written 6 programs. I will show that, right? So then changing the program, so that sometimes when you are using the loop, when you are using the for loop, so that is when you are reducing the number of iterations, so that definitely the time complexity will be increased. Suppose if you want to find out the prime number, either given number is a prime number. So then we have to repeat from 2 to n minus, so this is less than n. Or sometimes you can take 2 to less than n by 2 or 2 to square root of n. But when we are using that, suppose if you want to find out either 25 is a prime number or not, so that is one case you have to repeat 24 times, or in another case we have to repeat in 12 times, and another case with the 5 times repetition of loop, we can say that either is a prime or not, right? So that is the front end. And the next, intermediate code. Already we have studied some intermediate code. Here is in the intermediate code generator can do improve loops. So here is it also improving the loops and procedure calls. Here is also it produces the procedure calls. For example, it is a small program. Instead of using the functions, we can use the macros. So that is address calculation. Suppose here is also when you are using this address calculation, that is either in the symbol table usage for searching of a particular instruction or particular values. So that is what are the algorithms we are using, how best algorithms we are using, that will be specified in a symbol table. So that is everything. So that is it take the symbol table, and so that here is intermediate code also concentrate on code optimization. It concentrates to improve the loops. So that means when the loops are improving, so that is the loops means here is 90, so 20 rule is there, 90-20. That means here is for 20 work, 90, so 20 work, 80% repetition will be done. So to avoid that, we can use that is intermediate code, and procedure calls also we can use. Our next, that is procedure calls. Already we have studied 4 types of user-defined functions. So without arguments and without return values, with arguments, with return values, also suppose with arguments, without return values, with return values, like that. 4 options are there. So that means which function we have to use, that will be decided by the intermediate code of this one. After that, we can use the code optimization. It is optional phase, but even though it is very important. So the optimizer can do user register. This optimizer can assign the user register, select the instructions, do peep holes transformations, right? So these are the main functions of code optimization. And then in the front end we can achieve the code optimization. In the intermediate code we can achieve the code optimization, and the next separate we can use the code optimization. So for example, what is the importance of the code optimization means? For example, same C compiler. So we can run on desktop system, on laptop system, even on the cell phone also. So that means here is the same operations when you are implementing on the same with the less memory means there compulsory we require code optimization techniques. So organization of optimized compilers. So that is the code optimization phase consists of control flow analysis. So that is the data flow analysis and application optimization or transformations. The code optimization, that is the any optimized compiler, so that will contain three parts. One is the control flow analysis, data flow analysis and transformation analysis. So for example, in the control flow analysis means how the flow of control started from, so that is the main to end of the thing. How many paths are available, what are the achievable paths and what are the non-achievable paths. So that's why here is the flow, control flow analysis will identify the flow of program execution by selecting the shortest path like that. So next data flow analysis. Data flow analysis means when you are given the input values, so we are generating output. So that is in what order we are giving, so that is what type of data we are giving, how the data is flowing and how we are getting the data, everything will be analyzed in the, so that is optimized compilers. For example, when you say that a quick sort, so suppose when you are given the input values, all input values in the ascending order or descending order, so definitely you can get the, so that is the worst case time complexity. Suppose if you are given the randomly, so it may take best case time complexity or average case. Right, here is the data flow is also very important while you are giving input to the stand. So that data flow analysis is analyzed in the code optimizers, optimized compilers and application optimization. Application optimization means how to write the program. So for example, when you take the GCD of two numbers, so that is the one program, it may be take 23 lines. But I wrote that program with 5 lines. I will show in the, so in this, at the last slide, I will show that. So same GCD of programs, it takes the 23 statements, but when I am reducing that program, so it takes only 5 lines. But definitely it will increase the execution speed of the program. That's why, so it also concentrate on application, so that is application optimization. The code generator produces the target program from the optimized intermediate code. Intermediate code is independent from the source and target code, so optimization can be improved. So that means here is the intermediate code. So suppose when you are using that, so here is the intermediate code, we can use the code optimization. So this is also not in machine generated code. So that's why here is an intermediate code, whatever is not possible to optimize. So here is with the help of this code optimization phase, so then we can achieve the target. For example, you see that there is a program, the quicksort program. So that is in the Aho Woolman, Ravi Sethi, they have taken the same algorithm and they explain. Suppose you see that, so that is the consider the example of quicksort program. I think I wrote this quicksort program. So then here is we are taking this, but already you are familiar with quicksort. I don't want to go in depth about that how they are written the program like this. Here is it is a, so the partitioning algorithm, already we know that. We can take the pivot element and we can delete the list in the two parts, so suppose 2 parts, and so that again that is the 4 parts or something, we repeat that process and until to arrange the elements in the ascending order or descending order. Already we know that, right? So the same code, but when you are written in the C programming, but this will be, so suppose you have to execute this program. You have to execute means how do you execute it? First you have to construct the parser, either top-down parser or bottom-up parsers. You have to define the grammar. After that, based on the grammar, so then you have to convert into parsers. So that is either top-down approaches or bottom-up approaches we can use. So after that, we can assign the value. So we can make it as a so that is we can make it as a syntax tree, and after that we can make it as an annotation tree. And then with the help of dependency graph, we can execute the procedure. So for this one, the first one is you see that, so in the dependency graph or acyclic graph, no? Suppose if you want to write that, so the same program, whatever are taken in high level language C, it is converted into 3 address code. In the intermediate form, it converted into 3 addressing code. You see that in the 3 addressing code, so the same thing where I is equal to I plus 1. But here is we are not using while loop and we are not using for loop. Simply, so that is if go to statement. If the if else go to statement, here is we are using, right? So but because when you are using the if statement or jump statement, go to statements, all are available in the machine language. So that is assembly language or some other low level language. That's why. So they are converting that into, for simplification, 3 address code they are written. After writing this 3 address code, so these are divided into blocks. For example, you see that initialization part up to this 4 statement considered as a one block, and the next to 5th to, so that is the 8th, they are considering another block, and the 9th to 12th is another block, 13 to 22 is a one block, and the next to 23 to 30. So these 30 statements are divided into 1, 2, 3, 4, 5. 5 blocks, right? So that means these 5 blocks are constructed in the form of that is the DAX tree, that is the directed acyclic graph. But you see that here is when you are using the block 1, block 2, block 3, block 4. But here is suppose here is, so that is here is they are mentioning that like this. Suppose if I is greater than 0, then go to 23. So then here is suppose we are using if T3 is greater than V, go to 5. So that's why here is the loops also mentioned like this. 5 means within this, and these are the loops, these are the blocks, right? So now we constructed this program, right? We constructed so 3 address code and constructed the graph. That is the direct acyclic graph. But in this case, suppose here is our main aim is you have to reduce the program size. Definitely when the program size is reduced, automatically execution speed will be increased, and the same way storage capacity also reduced, and it uses minimum number of resources, right? So then how to reduce this? Here is optimization depends on various factors. Suppose if you want to optimize any program, so that depends on various factors. That means which variables we are using, so that is the which loops we are using, which decision making statements we are using, whether you are using the pointer or not, or functions, files. That means here is, so on that case you have to see on various factors. For example, suppose when you are using that, so the first one you see that memory management. So that is the first one is the memory management. Memory is also very, very important. Suppose here is, suppose already in the intermediate code I explained that. Suppose when you are constructing the syntax tree, if directly when you store that syntax tree, it occupies large amount of memory. So then if you want to search for that, definitely it will take the, so that is the more time for searching. But here is, suppose if the memory size is increasing, definitely, so that is execution speed will be reducing. So that because it has to search in the different memory locations. So next one is the algorithms. I think in the morning we are showing the design and analysis of algorithms. What is the principles of the? One is the optimality principle of the DA is the less, so that is the reduces the storage space, that is the time complexity and the space complexity. So time complexity for reducing the, for increasing the execution speed. So that is the space complexity means that is reducing the storage. And execution time. So that is the execution time is also depends on algorithm. Suppose if the algorithm size is very small, then its execution speed will be increasing. Programming languages. Programming language. Here is the programming languages also plays a vital role. For example, when you are taking the basic programming language or Pascal programming language, so and the same thing when you are comparing with the C, if you want to execute some program, if in the C in the Pascal, if it takes, so that is the 1 minute of time for execution, so the same thing in the C programming it takes only 1 second of time. You see that. So that is the C program is, so the 59 times faster than Pascal and basic programming language, right? So that's why when you are writing the programs in the C, definitely it increase the execution speed of the program. So function preserving optimization, functions preserving optimization. So without changing the computation values or functions, so we can improve the execution speed of the program. Loop optimization. Already we know that the loop optimization, that is 80 and 20 rule. Here is our loop optimization. Generally we can call it as 80 and 80-20 rule. 80-20 rule means for working 20 percentage, the loop will be repeated 80 percentage. A loop will be repeated 80 percentage. That means here is, so most of the time is wasting with the loops, right? So then, so that these are the main various factors. So we are using for code optimization. But when you are concentrating on this, we can reduce the code optimization. The principal source of optimization. So there are two types of optimizations. One is the local optimization and another one is the global optimization. Local optimization means it can be performed by looking only at the statement block. So suppose within the block, if you are trying to reduce the code size, so then that is called local optimization. For example, when you are taking, so the program already I have shown that quick sort, that will be divided into 5 blocks. So suppose within the block, if you are trying to, so that is reduce the program size, that is called local optimization. The global optimization means it can be performed by looking at on entire program. On entire program, if you are trying to reduce the program size, that is called global optimization. Either you can apply the global optimization or local optimization, or sometimes you can use the both optimization for reducing the code. So the many optimization techniques can be performed at both local and global levels. The many optimization techniques can be performed at both local and global levels, right? The local transformations are usually performed first. That means here is when you are taking the local optimization means, so the first local transformation is nothing but local optimization. So first local optimization is performed. After that we can go for global optimization if you want to perform both at a time, right? So that is the function preserving optimization. You see that. So the program preserving optimization, function preserving program. It can improve the code optimization without changing the function it computes. So without changing the computation, it will reduce the time. So you see that. So some of the examples of function preserving optimization are common sub-expression elimination. These are very, very important for gate. So common sub-expression elimination. And the second one is the copy propagation. Third one is dead code elimination. And fourth one is constant folding. So that means the 4 ways to reduce the code. One is the common sub-expression elimination, copy propagation, dead code elimination, and constant folding. What do you mean by sub-expression elimination? I will show with an example, right? Here is, if the expression is repeated more than one time in the code is called sub-expression or duplicate code. The sub-expressions means if the expression is repeated more than one time in the code is called sub-expression or duplicate code. For example, so in the quicksort you see that. So suppose here you see that the assignment statements 7 and 10 have common sub-expressions 4 into I into 4 into j. Suppose you see that, say T7. Suppose here is when you are using that, here is you can see that here is a 10. Suppose you see that 7. So that is 7. Suppose here is you see that it is a 7. So 4, 8, and here is also we are using same. So 4 into j, and here is you see that the 6th one, here is also we are taking 4 into I, and the next that is here is another one is 8th one, it is also, so that is a 4 into j. So that means the 2, 8 and 8. Suppose here is in the block. So suppose when you are using that, sorry, here is 6. You see that, and 6 is 4 into I. And here is another one is, suppose if I take a 10th statement, so then here is within the block, so that is the repetition is the duplicate expression, duplicate sub-expressions. Well, that's why here is exactly what they are doing. So then here is, so T6 and T7, both are having is equal to 4 into I. So instead of writing these two, we can write only one. So that is, we are writing only T6 is equal to 4 into I. So but here is in the 10 and 8. So the T10 and T8 are having the 4 into J, 4 into the same kind of expression, but here is we can eliminate the 10 and we can eliminate the 7 so that so we can make it as a so that is a compact code. You see that within the block we are eliminating, right? And this is one example, right? So that means here is the two statements are reduced. So that's why this kind of thing is called sub expression. Suppose if the same statement is repeating more than one time, if it is repeating more than one time, that is called a duplicate code or sub expressions. So if the duplicate code is available or sub expressions are available, so then we can eliminate. That procedure is called, so that is the so sub expression elimination, right? I have understood that. So they are eliminated by using 6. So that means here is we are reducing two statements. So when suppose here is suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 statements are there. Suppose each one will take in the 1 nanosecond for execution. And 9 nanoseconds it requires. But after eliminating these two, it requires only 7 nanoseconds. Right? So that's why we are reducing the program size as well as we are increasing execution speed. So that is after eliminating after elimination of all the blocks. So then here is we got this graph. Suppose you see that most of the are eliminated, B6 or B4 like this, right? So that is this is the sub expression elimination, right? So that is so suppose you see that another example of sub expression. You see that A is equal to B plus C. A is equal to B plus C. B is equal to A minus D. C is equal to B plus C. But when you see that the two values, suppose here is when we see that, so that is the A and C, both are same. A is equal to B plus C and the next C is equal to B plus C. So then here is, instead that is the same code we are using. So that is instead of 2 times, either we can eliminate A or we can eliminate B. So then, so that is also we can use sub expression of this one. So after eliminating this, the graph will be, the size will be reducing. So here is A is sub expression code, then delete node A. So from this one, when you are deleting the node A, so then definitely that is a 1, 2, 3, 4. Instead of using 4 statements, we are using 3 statements. That is the sub expression elimination or duplicate. So the statement code elimination. So this is the one way. So for eliminating the code. So next one is the propagation. That means here is the most of the cases the students will be doing like this. So that's why the former Vice Chancellor of JNTU Anantapur, then Dr. Professor Venkatram Reddy sir said that. So if any student is write 10 C optimal programs correctly, he offered job in multinational companies. That means here is, but writing program is not important, but writing, so that is the optimized program is very important. So if you want to write that optimization, definitely, so you will be selected in any companies or so like this, right? But analysis is required here itself. So copy propagation. So another technique is copy propagation. So I think you understood that sub expression elimination or duplicate code. This is very important for GATE. Sub expression elimination and dead code elimination, right? Another one is the copy propagation. So assignment of assignment form X is equal to Y. Generally are called copy statements or copies. But when you are using X is equal to Y, it is a Pascal statement. So but when you are using X is equal to Y, it is a copy statement or copies we can call it as. The idea behind this is this to use Y for X whenever possible. So after the copy statement X is equal to Y. For example, here is only 2 variables. X is equal to Y we are assigning. But when you are using X is equal to Y, Y value is assigned to X. After that we are using X within the, so that is the next statement of the program. But why you have to assign X is equal to Y? Why you have to use the statement directly? Why can't you use Y instead of X? But here is when you are using X is equal to Y, So it takes some time for assignment. Suppose without using x is equal to y, directly we can use y. So then automatically the propagation time it will be the copy propagation time, right? I will understood that unnecessarily you don't assign any values to any variables, right? So instead of that, suppose for example you see, but here is in the program most of the cases we write a is equal to d plus e, a is equal to d plus e, and b is equal to d plus c. But when you see that within the program, but when you are asking that write a program to find a and b values. So most of the cases directly we can write like this: a is equal to d plus e, b is equal to d plus e. But here is, so that is the two are same, are assigning to this. So that's why instead of using these two, only this value is assigned to only one. C is equal to d plus e, and in the same way, so t is equal to d plus e and t is equal to d plus e. Again we are assigning a is equal to t, and here is a b is equal to t and c is equal to t. So but when you are using that, here is a more number, but in the 3D addressing code, and here is we can assign the values to this, but it takes the more time for this one, right? That is the copy propagation. So that is the form of the common sub-expression elimination for this quicksort. In the quicksort, so when you see that the blocks, so the later on you go to the blocks. So because in the block, suppose you see that in the block 5, B5, we are given x is equal to T3. X is equal to 3, 2, 3. T3. But here is directly we are using T3. But here is x means, for example, so x is equal to T3 and directly we are in T3. But what is the use of using this x? What is so that's why here is x is equal to 3. That is unused expressions can be directly eliminated. For example, some people can write x is equal to T3. But here is you can write a of T4 is equal to x. So that is also correct. There is no doubt about it. But when you are here writing x, so then here is extra statement we are using. When your extra statement is using, the code size will be increased or execution speed will be decreased. So that is these are the so next one is a dead code elimination. So next one you can see that a dead code elimination. What do you mean by dead code? But in the C programming, so many times I think you observed that. So you are declaring variable in the declaration part, and but you are not using that variable anywhere in the program. Then what kind of warning it will show? So that is the variable a declared cannot be used anywhere in the program. Why that will be showing is when you are declaring the variable, the memory is allocated for that variable in the symbol table. Memory is allocated in the symbol table. So but memory is allocated, so but you are not using that. That is the useless variable. But here is that's why the C compiler will asking that it is you declare this variable, but you are not using this variable within the program. So that is the so that's why it says that. So it is a warning that will be giving. Now you see the dead code elimination. So this is also very important. What is the dead code? How we are eliminating the dead code? So that is the code which is never be executed within the program is called dead code. That means the code which is never be executed within the program is called dead code. That is example of unreachable code. And sometimes we can get the error of unreachable code. And second one is unused variables. So that means the dead code means the code which is never be executed within the program is called dead code. But here is example of the dead code is unreachable code and unused variables. But here you see this example. So for example, you see this is here is I written that function. So for finding the sum of two numbers, I written this function for finding the sum of two numbers. Here you see that int add int a comma int b, and here is declaring that variables int x comma y comma z, and return a plus b. Return a plus b. After return, I have written printf hello computer and printf how are you? Hello computer, how are you? I return the statements. whether these two statements will execute or not. Definitely, while you are executing this program, so whenever the compiler will find the return statement, immediately the control goes to the main program. Immediately the control goes to the program, but these two statements never executed. These two statements never executed. So then we can call these two are the dead code. This kind of statements are called the dead code. I think you understood that. What is the clear idea of the dead code element? Dead code means the code which is never be executed is called in the program is called a dead code. For example, so that is in the return statement. After return statement, you write anything that will not be executed. So in that cases, the compiler will. But here is that will shows that here is you are using. But these are stored in the memory locations because that will be converted into a stream of tokens and stored in the memory. That is the memory is wasted and the time is also wasting for at the time of compilation. At the time of execution, it will not execute. So next one is unused variables. Unused variables means you see that within that I am using so int x comma y comma z, but I did not use this variable within the program. Within the program. So then these are unused variables. So you have to remove this unused variable from this code. Or this is called dead code elimination. But if you want to make it as an efficient program, only you have to write these two statements. Int add, int a, int b, return x plus, return a plus b. Then with these two statements, we can write this program. But how many statements are there? 1, 2, 3, 4, 5. But here is the 3 are, so that is unused, unreachable statements, right? So when you eliminate, this is called dead code. This is called dead code. So if you are eliminating this dead code, so then we can call it as a dead code elimination. We can call it as a dead code elimination, right? So within the program, when you are writing that, first you have to analyze the flow of controls and data controls. You see that. So what are the variables are using, what variables are not using, so that we can eliminate that variables. And the second one is, so then you analyze the flow of controls. Either each and every statement in the program is reachable or not. If the statements are not reachable, so then you eliminate from that. You consider it as a dead code and you can eliminate the things. But in the code optimization, we can eliminate the dead code, right? So that is one is the sub expressions elimination. So that means here is the duplicate statements will be eliminating. So that is here is the copy propagation. So unnecessarily instead of using the same statement assigning to other variables, so then directly use that variable, that is the copy propagation. And next dead code elimination. Here is unused code, unreachable code will be removed from the program. But when you remove that, definitely the code size will be increasing, so code size will be reduced and execution speed will be increasing, memory is also reducing. So for example, another one is the constant folding. So that is the process of recognizing and evaluating constant expressions at compile time rather than at runtime is called constant folding. The process of recognizing and evaluating constant expressions at compile time rather than at runtime is called constant folding. For example, so in the previous class, I explained that, so suppose while data is stored in the symbol table in the 3 addressing code, so but we are storing only the variables but not constants, right? Why we are not storing that constants in the thing means, but here is that is because of the constant folding. But when you are using the constants, so that will be at the time of compilation, it will be executed. For example, you see that this example of program. So here is written that. So suppose y is equal to y plus 8 plus 7 plus 4 plus and 12. But when you see that here is, so how many times, suppose if I am given I is equal to 100 times, if I, sorry, n is equal to 100 times, 100. So this loop will be repeating 100 times. 100 times means how many statements are executing, that is 1, 2, 3, 4 and 5. So the 5 arithmetic expressions are using. But suppose each expression are taken 1 nanoseconds, that is the 5 into 100. So that is the 500 nanoseconds it will take for repetition. So already I told you, that is the 80 and 20 rule it follows. So for performing the 20% of work, it takes the 80% of time, right? So this is the, so but here is when you are using this, why is it, this is the constant, right? 8 plus 7 plus 4 plus 12. But you need not give the values at the runtime. So that's why at the time of compilers, automatically it find the sum. Suppose 8 plus 7 or 15, 15 plus 19, and 19 plus 31. So 31 is added to y. So suppose we have once that will be 31. So suppose here is the 500 times we are using, right? At the time of compilation, that will be adding y is equal to y plus 31. So, but here is one way of that is a constant folding. But even though here is, it will having the more time. But instead of that, suppose, so we can take this expression, we can declare outside. Suppose you see that for I is equal to 0, I is less than n, I plus plus. And here is, instead of writing this y, so suppose y is equal to y plus plus, or simply we can write the same statement. So suppose instead of writing this, so we can write, so that is the y is equal to x, y is equal to, so that is the y is equal to y plus x, or we can write short notation y plus equal to x. So, but when you are using that, so that is how many times that loop will be repeated here comparatively. So, suppose here is 5 expressions are there 100 times. 5 into 100 means, so 500 nanoseconds are required for this program. But here is the only one operation. That is only one operation is performing. That is the only 100 times. You see that? So that is the 400 nanoseconds we are reducing with the help of that constant folding. You see that this is outside we are writing the code, right? But this is the one way of writing the program. But most of the people, they are thinking that, so that is the code they are writing like this. But instead of that outside, we have to write. So this is also, so on this one also, that is the compiler concentrating on the code optimization writing. So that's why when you are giving this kind of things, automatically sometimes the KSC compiler will give the warnings like this, a constant folding. I understood that the constant folding means, so if you are using any integer constants at the time of compilation, integer will be executing, integer part will be executing, and that means the constant values will be executing, but not at the runtime. The variables are executing at runtime, so but the constants are executing at compile time, so that is called constant factoring. With the help of this also, we can reduce the storage space. How we are reducing the storage means, so here is the 4 integers are the 4 values are there. These 4 values you need not to store in the symbol table. So directly we can calculate it. So but suppose if you are using at the runtime, so compulsory you have to store these values in the symbol table. So that's why here is, it will reduce the storage space. That's why we can call it as a immediate addressing mode. Here is we can use the immediate addressing mode if you are good at CMOD, right? I know you understood that, right? This is the constant folding. And the next one is, the next technique is loop optimization. Next one is called loop optimization. So here is in the loop optimization, I think you understood the thing. So loop optimization means 3 types of loop optimization. One is the code motion, so induction variable elimination, and reducing in strength. That is 3 types of loop variables. That is the code elimination. Suppose here is the code motion. Another technique is induction variable elimination and reduction in the strength of operations. So, but when you concentrate on these 3, when we are writing the program, so then definitely, so it may be violate the 80 and 20% rule, right? So that is for 50% work. Suppose if you properly use that loop, so that is the 50-50 chances are there. 50% work and 50% loop, right? First I will see that code motion. What do you mean by code motion of this? But here is, it moves code outside the loop. That is it moves the code outside the loop. So this is also one example of code motion. X is equal to, suppose instead of writing within the loop, we are writing outside. So this is also example of code move. So that is when you are in the code moves, that is it moves it moves code outside the loop. Thus, transformation takes an expression that yields the same results independent of the number of times loop is executed and places the expression before the loop. For example, suppose when you are using that, so here is a y is equal to y plus we are written. But here is instead of that, that is a 1, 2, 3. The 4 operations are assigned to x, that is the 3 operations. So that's why every time we can use y is equal to y plus x. So then automatically it will reduce, right? So instead of writing the entire code within the loop, so that is the common code, that is the common code or so that is the common code or constant factoring code may be written before the main loop. So that's why it can reduce the code. This is the example of this. For example, you see that. So that is the most of the cases we can use while I is less than or equal to limit minus 2. So in the while statement in the C programming, I think so that is we got some experience about writing that programs, right? For example, if I given a program, write a program to find so the arrange a list of elements whether in ascending order or descending order. So there we are taking I is less than n minus 1 we are writing. So that is when you are using this thing like this, but here is while less than or equal to n means, so suppose if the limit is 1000, if we assume that the limit is 1000, how many times it will repeat? 998 times it will be repeating. 998 times it is repeating. But every time, so that is the limit minus 2. This operation is performing. This operation is arithmetic operation is performing. Every time limit minus 2, limit minus 2. So that's why the same statement will repeat it 998 times. But how to eliminate that? So for example, you take that is outside, that is the code motion means, so that is the t is equal to limit minus 2. So automatically we can see that here is 998 times and this t is used within the loop, it's in the while loop. So then automatically we can reduce these number of operations. We can reduce this number of only simply the comparison operation it will perform, no other, because t throughout the program, so that is throughout the loop t value does not change. But even it does not change, we are using limit minus 2. So then here is, you see that it is a small code. How we are improving the optimization means, so for example, suppose here is when you use this form of the while, so the 998 nanoseconds of time it takes, but here is when you are taking this, here is it takes only 1 nanoseconds. You see that how we are reducing the, so how we are increasing the execution speed, right? I answered that this is called code motion. So within the for loop or within the while loop, or suppose when you are using some expressions, so the most of the cases they are using for I is equal to 0, I is less than n, I is equal to I plus 1. They are writing I is equal to I plus 1. So every time I is equal to I plus 1 will be repeated. So that is a one arithmetic operation will be executed. So instead of I is equal to I plus 1, when you are using I plus plus or I plus plus, only the increment operator will be using, right? So that's why here is, so that is the code motion. Code motion means, so suppose within the loop, if the same code is repeating more number of times without changing its output value, then we can write that code outside of the loop. That is called code motion technique. With the help of this code motion technique also, we can eliminate the arrays. So next, induction variable elimination. Indexed variable elimination. That means indexed means any two variables are said to be indexed variable. Any two variables are said to be indexed variables. If there is a change in any one of the variable, then there is a corresponding change in the other variable. So suppose if there is a change in any one of the variable, then there is a corresponding change in the other variable. So this kind of variable, suppose if the value of one variable changes, another value will be changed. Other will be changes, just like twins in Hello Brother movie. So you can see that, right? So these are the index variable. So in that cases, we have to eliminate. Suppose you see that. So that is the before. Suppose in the block tree, the SQ, so that is the quick start. We are writing j is equal to j plus 1. T4 is equal to T star j. T4 is equal to T4 into j. T5 is equal to A of T4. And if T5 greater than B, go to B. So this is the variable. But here is T4, we are using that T4 is equal to 4 into j. 4 into j. Generally, the star operation takes star operation, division operation takes more time than addition and subtraction. So then, if you replace this star with the, so that is the plus operator, so then automatically it increases the execution speed. At the same time, the value may not be changed. For example, you see that here is suppose B itself, suppose here is written like this. Then you see that the same expression we are written like this, T4 is equal to T4 plus 4. But here is this increase the execution speed. But here is a T4 4 into J. So but here is only we are concentrating on the 4. So here there is a chances of getting wrong results. For example, if I kept that, so I is greater than or equal to 0. So here is it more time like this. So these costly operators are replacing with the another variable that is called index variable elimination. That means here is j is equal to A4 into j we are taking, 4 into j. Then you compare this. So suppose j is equal to 2 now. So 2 into 4, that is equal to 8. Here is the first it will take, j will take 1. So that is the T4 plus 4, 4 T4. Again second time it will be added second 4. That is equal to 8. So both the operations are same. But here is, this will take very less time comparatively this one. This take less time because the costly operators are replacing. So that's why in the data structures, so instead of using binary search tree, it is better to use Fibonacci search tree. In the Fibonacci series, we can replace the costly operator division by, so that is a plus and minus, right? So induction variable elimination. Programs for induction variable elimination, it reduce strength reduction of this one. It will reduce the strength of the variable. Another one is reduction in strength. Reduction in strength. So suppose in the reduction in the strength means instead of using costly operators, you can use a low cost operator. We can replace the costly operator with the low cost operator. So then we can call it as a reduction in strength. For example, you see that replacement of an expansive operator by cheaper one. That is called reduction in strength. The replacement of an expression operation by cheaper one. For example, you see that here is a step T2 is equal to 4 into star in the B2. So that is in the block 2 of quick start. We use that T2 is equal to 4 into I. T2 is equal to 4 into I. But here is the star is a multiplication is a costly operator. Why multiplication is a costly operator? So number of registers are required. Suppose moving for digit to digit like this. I don't want to go in depth about it. Replacement with the T2 is equal to T2 plus 4. If the statement is replaced with this, but both are similar, both are same, but here is we are in the plus operator, we are using star operator. So that's why it takes very less time than this. For example, if you are using 100 into 100, 100 into 100, that is 10,000, right? So suppose 10,000. 10,000 times, so suppose here is the same value, but physically we can see that that is the 100 into 100, it will give the 10,000 values. But instead of using 100 into 100, the 100 will be added 100 times with the addition. 100 times will be used. So the definitely Adding 100 times 100 is getting very less time than 4 into I, 100 into 100. So that is the concept. Suppose in the computer organization, that is the number of registers are required for multiplication. So that's why. So that is the costly operator can be replaced with this one. So that is this is the reduction in the strength. This replacement will speed up the object code if addition takes less time than multiplication, right? So induction to global data flow, you see that the compiler needs to collect information about the program as a whole and to distribute this information to each block in the flow. That is a global data analysis. That means they collect the information totally and it assigned to the subparts. The data flow information can be optimized compiler collection by process known as the data flow analysis. The generation and killing of process depends on the desired information and the data flow analysis to be solved. Depending upon that data, either which path you have to select. So based on that, a remaining code will be eliminated. Suppose in the if else statement, we can select one block in between two. So that's why either which block you have to select, that's depend on data flow controls, right? Data flow analysis affected by the control construction in the problem. Optimization block code, here is we can use. A basic block code sequence is entered into the beginning and ending. So that is a code optimization, that is the block optimization. That means when you are taking while loop or for loop, so that will be having only one entry and only one exit. So in between that we can write any number of programs and any number of statements we can execute. But if you do any above expression, above technique to eliminate the code of that block, that is called basic block coding, right? Basic block is equal to sequence of instructions with a single entry and a single exit. That means here is the for loop, while loop or do while statements. Data flow analysis structure, right? The flow graphs for control flow construct such as do while statement have useful property. There is a single beginning point at which the control enters and a single end point at which the control leaves. That means when execution of the statement is over. That means here is suppose when execution, that is the control flow, we can show with the data flow diagrams or control flow diagrams, right? So these are the main techniques we can use for reducing the code optimization. But generally most of the cases we are saying that the code optimize, but in the olden days we were thinking that, so that is at that time we were using the procedure oriented programming language. That's why you can see that there the design and analysis of algorithms. But there we are concentrating how to reduce the program size and how to reduce the storage space. But nowadays we are using object-oriented programming language. But here is you need not to concentrate that code and we are mostly concentrating on the output. So but in that cases, so nowadays we are using cell phones, laptops, or next desktops. So the different devices we are using for executing the same code, even though you see that. So now I am giving this lecture, but you are watching in your cell phone. But suppose in the olden days there was no cell phone. At that time, the code optimization was not required. But here is the code optimization should be required. But here is the compression techniques they are using. Video compression techniques for increasing the data transmission rate, like that, right? So that's why here is the code optimization is very, very important. In the code optimization also, we are getting more questions. So some questions from that, but almost all the questions are only in the theoretical manner. So before going to explain this gate questions, I will show that how to write the program code by using this one. Suppose, so I told you, suppose how to write the program. Suppose here is GCD of two numbers. So that is, so how I am optimizing this code. For example, when you see that everyone is familiar about GCD of two numbers. So suppose by default, suppose if you are Navi user, so simply you can write like this. When you execute this program, you can get the GCD of two numbers. When you are given the 64 and 12, you can get the 4 GCD. There is a no wrong. But how many statements are there in this program? 23 statements. But here is the program size is increasing. 23 times 23 statements are there. So, but how to suppose when you are taking the 20 through, definitely code will be the same code we can write like this in the GCD of both positive and negative numbers. So then here is in, so that is you see that here is only it takes 15, but here is you see that code, right? I don't want to explain this code, but you are familiar with GCD of two numbers. Here is I written a small code. So comparatively to that, here is it has taken 15 lines. This code has taken 15 lines of program. But another third variation of GCD of two numbers I wrote. So that is here is it took 14 lines. It took the count this 1, 2, 3, 4 comments it doesn't consider. So that's why it took the third one 14. Our next one is again we reduce this. So the C program for finding GCD of using a recursive function. Here is I applied the recursive and main program. Even you written the recursive and main program, it takes 13 statements. It takes the fourth version also it is taking 13. But here is a fifth statement, it takes the fifth program, it took only 12. Fifth program it took only 12 statements. That means the number of lines are reducing, right? And the sixth one, you see that GCD of two numbers by using for loop. So within the statements were written, it takes the 10 statements. 10 statement. So finally I wrote one program that is the seventh program, but the number is again 4. But in the seventh program, within the 5 statements I wrote this program. Within 5 statements I wrote the GCD of two numbers. So how I wrote this program? But everything is kept within the for loop only. Everything kept within the for loop. You say within the for loop, I mean number 1 is equal to I given in 64. Number 2 is equal to 12. And the number 2 is not equal to 0. Number 2 is not equal to 0. Then we are doing temp is equal to number 2, comma. Number 2 is equal to number 1. Number 2 is equal to number 1 mod number 2, comma, number 1 is equal to temp. Exchange and everything I written. At the end I close with the semicolon. That is the null statement, right? So, but it is repeated as long as, so that is n is not equal to 0. You see in the for loop there is a one condition. You can use any 0 or any number of initializations. You can see the 0 or any number of incrementing variables or decrementing variable, but only one condition is required. Only one condition is required. So, but in that case, as you can see that, so but here is initializing, so that is the number 4. You see that here is a number 4 is equal to 64, number 2 is equal to, here is I am using comma, right? So that is the comma. This is up to this one is the initial part. And so suppose here is n, so suppose here is n2 is not equal to 0, it is a condition. And here is the same code I written. That means here is when you are writing this, I took only 5 statements. So you see that, so the same program when you are writing in the first case, so 23 lines it took, 23 lines. So that is the second case 15, 14, 13, 12, 10 and 5. And 5 statements it has taken. But so suppose, so if you want to reduce this program size, so you can write printf also within the for loop. You can write printf also within the for loop, or all the numbers also you can declare within the for loop. That means with a single statement we can write entire program for finding the GCD of two numbers. But when you are writing everything within the header of the for loop, 100% it will increase the execution speed. I have understood that how we are reducing the program size. But here is when you have taken a particular problem, so there are so many solutions. Among the solutions, you can choose the optimal solution. That means which reduces the number of lines of the program, which increases the execution speed, right? So that is, I think you understood that here is for only one GCD, I wrote 7 programs, 7 different algorithms, right? I understood that this is the code optimization. But most of the cases, everyone they can write this program. But when you say that GCD of 2 numbers, everyone they can write blindly this program. Suppose they can read the 2 numbers. If the number 1 is equal to GCD is equal to number 2, else if number 2 is equal to 0, GCD is equal to, so the number 1. If number 1 is less than number 2, then interchanging, or otherwise remainder or same. So this is blindly we are writing. But when you are writing that, this code, you are not a good programmer. But if you write a program code with 5 lines, 5 statements, then you are the good programmer. I think you understood what the former Vice Chancellor, Professor Venkatraman Reddy, he was my guy, so my guru. So that is, he was my teacher, right? So, but that's why I'm saying that. Suppose while he was in the so that in the position of Vice Chancellor, he announced in the public meeting, if any student is able to write 10 C programs with optimal 10 C programs, he offered a job in a MNC company. But we can see that here is the most of the, so about 7 variations in the GCD I wrote. But if I try, I can get 1 more or 2 more things for reduction of this. So now we understood this, right? So this is the code optimization. When you are using that code optimization, for example, the 7th program, when you execute the 7th program, it is very easy to execute in the cell phone also. But the first program, somewhat difficult because it takes more time and more memory, because comparatively the cell phone speed is very less than, so that is the system. So that is a laptop. Laptops is also less than desktops or supercomputers like that. So that's why here is our intention is, so with while you are constructing the compiler, so you should follow you should obey the these rules and regulations of code optimization techniques. So that's why we can say that a C program is a C compiler is a more powerful. So because so it has a highest code optimization technique. So nowadays that's why most of the new generation programming languages they are using, so that is the part of SQL, so that is the C programming language, C, C++, Java, C#, or so next VC++, or so suppose Windows operating systems also written by using VC++. Most of the cases that will be depending on the C compilers, right? So, but when we can say that the C compiler is developing compiler is important, but optimized compiler is very important language, right? So this is the thing. First, you see that some of the questions what we got in the previous GATE as well as in the degree for computer science degree for TCS examinations or like this, right? For example, you see that. So, which of the following statement about the peephole optimization is true? Which of the following comment about peephole optimization is true? So that means here is when you say that peephole means it is applied to a small part of the code and applied repeatedly. So peephole means it is a small block of code. Peephole means it is a small block of code. So then here is a code optimization is true means you see that it is applied to a small part of the code and applied repeatedly. So then, so another one is it can be used to optimize intermediate code. It can be applied to the portion of code that is not contiguous. It is applied in the symbol table to optimize the memory requirements. But here is when you see that, so first thing is you see that here is we are using that is the code optimization, right? So that is here is we are using that is the peephole code optimization. It is a small portion of the code. It will be repeatedly so trying to eliminate the duplication, right? It is so that is the answer is yeah. It is applied to a small part of the code and applied repeatedly. Same code will be applied repeatedly so that we can make it as a efficient code. But it cannot be used to optimize the intermediate code. So it is not an intermediate code technique, it is a code optimization technique. It can be applied to the portion of the code that is not contiguous. So that means here is, this is also wrong. Why this is wrong means, it cannot be applied to the portion of the code that is not contiguous. Suppose if it is not in the continuous phase, so that is not in the continuous phase, so it cannot be, not in continuous, it cannot be used, but the particular portion will be selecting and do the process. So that is, the answer is A. It is applied to a small part of the code and applied repeatedly This is question number 1. And question number 2, you see that, which of the following class of statement usually produces no executable code when compiled? For example, you see that, so that is which of the code? A is the declaration, B is assignment statement, C is input and output statements, and D is structured statements. So that means, which of the following class of statement usually produces no executable code when compiled? Which is correct? So at the time of execution, it doesn't produce any executable code. Which one? Either A or B or C or D. So, but when you are using the assignment, for example, you see the structured element. When you are declaring the structured elements or structured data type elements, so definitely arrays or structures can be converted into executable code. So input output statements, this is also executing at the time of compilation, and then will giving out assignment statement. So that is, every assignment statement will either convert into executable statement. But the declaration, so the declaration means, the declaration statement, what is the use? It will identify either only the declaration part is, it will store the variables in the symbol table. It will store the variables in the symbol table, but it doesn't make it as a executable code, right? So that is, the answer is A, that is the declaration of statement. Everyone will convert it into, so that is executable code, but it won't create no executable code. It will create no executable declaration. Suppose int A comma B comma C, but it will not convert it into executable code, but these values will be stored in the symbol table. So that is, the answer is A. For the second question, answer is A. Next, you see the third question. Substitution of values for name is done in dash. That is, the whose values are constants. That is, substitution of values for names whose values are constants is done in local optimization, loop optimization, constant folding, and next strength reduction. Which technique it is? Substitution of values for names. Substitution of values for the names. Is done in the, that is, the A is local optimization, B is a loop optimization, C is a constant folding, and D is strength reduction. So that is, answer for this third question is constant folding. That means here is, for example, when you are using the pi value, suppose within the program, when you are using the pi value, so simply pi is equal to 3.141. But if the same value you are writing more than one times in the program, so instead of writing more than one time, so you declare it as a one name, that is the pi, define pi 3.141. Within the program, you can use the pi value, or that is a constant. Suppose the names are constants means, so definitely it is a constant folding. Already I explained that a constant folding is also one kind of technique, but all the constant, that is the rule such that all the constants values will be executed at the time of compilation instead of runtime. Right? That is the answer is constant folding. That is the C. Answer is C for third question. Have understood that? Right, fourth one. You see that fourth question. In compiler terminology, reduction in the strength means. Reduction in the strength means. What is the answer? Reduction in the strength. Reduction in strength. Already I explained that. T2 is equal to 4 into J. That is replaced with, so T2 is equal to T2 plus 4. That means here is, that is the reduction in the strength means if you want to reduce the strength of the operator. That means you have to replace the costly operator with the low cost operators. Example, my addition, plus and minus are the low cost operators comparatively star and division. So that means when the program contains suppose star and division, it is better to replace with the plus or minus. That is called reduction. Now you see that which is the correct. Replacing runtime computation by compile time computation. B. Removing loop invariant computations. Removing loop invariant computation. Removing common sub-expressions. Replacing costly operation by relatively cheaper one. In compiler terminology, that means answer is D. You can use answer is D. You see that? So that is the replacing. So that is in the compiler terminology. Reduction in strength means we have to reduce the strength of the operator, but not the strength of the program, right? So for this one, the answer is option is D. So next you see that fifth question. Which of the following statements about peephole optimization is false? Which of the following statements about peephole optimization is false? So that is, I think, same question. That is, here is, it is applied to a small part of the code. Then you see that it applied to a small part of the code. It is true, right? So that is, it is true. It can be used to optimize intermediate code. It can be used to optimize intermediate code. But here is code optimization is also comes on intermediate. That's why it is also correct. To get the best out of this, it has to be applied repeatedly. To get best out of this, it has to applied repeatedly. Yes, so that is in the third, I think, second question. Third question, I explained that. So peephole is a small part of the code repeatedly executed, right? So that is the third one is also correct. But fourth one, it can be applied to the portion of the code that is not in contiguous. That is, it can be applied to the portion of the code that is not contiguous. That means here is that suppose if the code is not in a continuous line, suppose first statement, second statement, third statement like that, but there it is not possible to use the peephole optimization. That's why. So answer is D is false. In the portion of the code that is not continuous, that is the D is the false. So that is for the fifth question. Answer is D. Now you see that sixth question. The graph that shows basic blocks and their successor relationship is called. That means the graph that shows basic blocks and their successor relationships are called what? One is A is the DAG, B is a control graph, C is the flow graph, and Hamiltonian graph. Which one is the correct? The graph that shows basic blocks and their successor relationship is called DAG can show the basic blocks. What it shows the DAG? Direct acyclic graph. It shows the direction of evolution of the program, right? The control graph that will show the control path. So that is Hamiltonian graph. It is not related to this. You can use in some other networks, computer networks, or some other case. Further this one. The flow graph. The answer is for the sixth one is the flow graph. So in the first for quarter for the quicksand, I explained that flow graph, right? When you are taking the code, that code, the related code will be make it as into number of blocks. So then within the block we can apply the code optimization. After that we can apply code optimization on entire program. So that's why it is for the sixth question answer is flow graph, that is C. For our sixth question answer is C. For the sixth question answer is C. That is the graph that shows basic blocks and their successor relationship is called DAG, control path, flow graph, Hamiltonian graph. That is the answer is flow graph. So then you see that. So in the syntax analysis phase, we are using that is the dependency graph. So next in the intermediate code generation, we are using the DAG, and here is we are using the flow graphs. Here is we are using flow graphs of this. Seventh question. In compiler, suppose you see that in compiler optimization, operator strength reduction uses mathematical identities to replace slow math operations with faster operations. Slow math operations with faster operations. Which of the following code replacement is an illustration of operator strength reduction? Here is the four statements are there. So which one is shows the operator strength reduction? Operator strength reduction. A. Replace P plus P by 2 into P, or replace 3 plus 4 by 7. Replace P into 32 by P is a shift operator, that is the right shift operator. Replace P into 0 by 0. Replace, so that is replace P left shift operator by minus 4 by P star, this one. So which one is the correct? But you see that P plus P is replaced by 2 into P. So there is a no operator reduction. Here is the, so this is the plus we are using the multiplication. So it is wrong, but you have to replace star with the addition. Replacing 3 plus 7 by 7. So that means here is also, we can, it comes under constant folder. It is a constant folder. That is the two constants are adding, but there is no reduction in the operator strength. So next here is suppose you see that in the C, suppose P star 0 by 0, there is no reduction, and here is also there is no reduction, but in the B, P star 32 replaced with the P 5 left 5 operator. That means here is we are using this is 32. So suppose whenever you are taking that any bit, suppose when you are shifting right side by 35 bits, so then it will be equal to the what? 32. It is equal to 32. So then here is the shifting is better than multiplication. That's why. So in this case, P star 32 replaced by, so P right shifting by 5 positions is correct. Suppose for the same thing we can write. That means here is the shifting operators having the, so the less power than slow, fast, the faster than multiplication. Faster than multiplication. That is why you are using. So that is the better than some 1 1. 4. Suppose here is a 1 1. Again 1 1 1 and So that is here is a 1. So suppose here is a 1, 2, 3, 4 times. So 4 shiftings plus 4, that is equal to minimum of 8. So that is our total 1 register are required. But when you are adding these values, but only one thing is required. Suppose all will be writing like this. So suppose the maximum it will take the 5 values. So that's why. So that is the operation. Suppose if you have taken the plus operation, so that is the plus is better than writing the values. But here is you have to use the shifting operator. First 4 you have to shift. For this one register is required. For this one another register, another register, another register. But here is only one register is sufficient. So that's why here is answer is that is the values. I think I have understood that. Okay, no problem. So next is the 8th question. In dash, the bodies of the two loops are merged. The bodies of two loops are merged together to form a single loop provided that they do not make any references to each other. They do not make any references to each other. In dash, the body of the two loops are merged. To generate these single loops provided sorry for the disturbance, provide each other. So that is the loop unrolling, strength reduction, loop concatenation and the loop jamming. So in the bodies of the two loops are merged together to form a single loop provided that they do not make any references to each other. They do not do any references to each other means both are parallel. So suppose there is no relationship between that. So then here is, in that case we can say that, so that is the loop, A loop unrolling, strength reduction, loop concatenation and loop jamming. So if they are concatenating the two and there is no differences between these two, means that is the loop jamming will be occurred. So that means for the 8th question we can get the loop jamming. Loop jamming of this 8th question we are getting loop jamming. I think you understood. So that is the loop unrolling. Loop unrolling means, so we can make it a single loop. And strength reduction, we are not reducing, loop concatenation. If the two loops are merging but without referencing means that is the loop jamming will be occurred. This is the 8th question. Answer is D. For this one answer is D. 9th question. You see that 9th. Loop unrolling is a code optimization technique. Loop unrolling is a code optimization technique that avoids test at every iteration of the loop, that improves performance by decreasing the number of instructions in the basic block. B. C is suppose so that is that exchange inner loop with outer loop, that reorders optimal operations that allow multiple computations to happen in the parallel. So that means unrolling. So that is loop unrolling means, so that is for this one answer is A. That is that avoids test at every iteration of the loop. It avoids every iteration of the loop. That means that avoids test at every iteration of the loop. So for example, when we are taking for I is equal to 0, I is less than or equal to 1000, I plus plus. But when we are using that, every time I has to check with the 1000. That means how many times it has to check? 1000 times it has to check. So before that, suppose when you are using unrolling, code optimization technique. So the first it will check that it set the one mark points. It set one the mark point. So suppose 1000 means it will taking 800 or something. So that is the 999 times. But up to that, without checking condition, it will be execution will be repeated. So when that whenever that reach the point, so then it will be checking the condition, right? But sometimes it will be for increasing the execution speed. Unrolling loop is also we can use. Every time we need not to check the condition, right? So for example, if we say that, suppose when you go to the hotel, so suppose you order for 20 copies. So every time you need not to count. First you will bring 2, next bring 2, next bring 2, next bring 2 like that. So after that, whenever you get after 15 or 20, from there it will start counting. So that's why here is also that kind of thing is called unrolling. Loop unrolling is nothing but sometimes the condition may be not be tested. I have shown that short circuit condition like that, right? That avoids the test at every iteration of the loop. So ninth question is answer is loop that avoids test at every iteration of the loop. I think you understood, right? Loop unrolling, that means that avoids test at every iteration of the loop. So only a minimum number of times it will be repeating, even if you given the condition, but every time condition may not be checked. So the answer is there. Field pool optimization is a form of loop optimization, local optimization, constant folding, and data flow analysis. Right answer displayed first, right? So, but here is suppose field pool optimization is a form of local optimization. It is a local optimization. Loop optimization means it has only one entry and one exit. So local optimization means a block of code without loops also. Only blocks code will be taking, and that blocks code is also trying to reduce. Or constant folding. Constant folding is only when you are using the integers. So that is at the time of compilation that will be executing in the execution. Data flow analysis. Data flow analysis can be used at the global fashion for analyzing the data, for setting the paths. Right? So that is the local optimization. That is the 10th question. Answer is local optimization. Answer that. Next, 11th question. 11th question is dead code elimination in mission code optimization refers to. What do you mean by dead code elimination? Dead code elimination means the code which is never reached and unused code. Unused code is called dead code elimination, right? So either what is the answer for this one? 11th one, removal of all the labels, removal of all labels, removal of values that never get used, removal of values that never get used. C is the removal of function which are not involved, removal of function which are not involved, and D, removal of module after its use. Which is correct? The dead code elimination in mission code optimization refers to which is remove of all the labels, remove of values that never get executed, never get used, removal of function which are not involved, removal of module after its use. But already I said in the definition itself that contains. So that is the removal of values that never get used. The removal of values that never get used. So suppose in the C compiler we can say that the variable A is declared and not used in the program. It will show the error like that, right? So that is the next one is it will show unreachable code. Suppose if you have written that program, So after return, whatever you write, that will not execute, but a compiler will show the warning, this is unreachable code, right? Unreachable code, it will be displayed. That is called dead code elimination, because this dead code elimination is implemented in the C program perfectly. So that's why C is a more powerful programming language. If you use variable, if you are not using that variable in the program, after declaration, immediately it will source. Our code is dead code is there. Then B, removal of values that never get used. This is the B is the answer for 11th question. And the 12th question. 12th question. In the context of compiler design, reduction in strength refers to. The context of compiler design, reduction in strength refers to what? So, A, code optimization obtained by the use of cheaper machine instructions. Second one is reduction in accuracy of the output. C is reduction in the range of values of the input variable. Reduction in efficiency of the program. Reduction in the efficiency of the program. What is the answer for this 12th question? In the context of compiler design, reduction in strength refers to code optimization obtained by the use of cheaper machine instructions, reduction in accuracy of the output, reduction in the range of values of input values, reduction in efficiency of the program. But here is reduction means reduction in the strength means either operator strength or instruction. Operator strength or instruction. So that's why answer is A. A code optimization obtained by the use of cheaper machine instructions. We are using the super machine instruction. That is the answer is A. For the 12th question, answer is A. So that is the code optimization obtained by the use of cheaper machine instructions. And 13. Some code optimizations are carried out on the intermediate code. Some code optimizations are carried out on some intermediate code, because I studied that is the DAG. So direct acyclic graph is better than what? So syntax tree. That is this 3 address code is better than these two, like this. That means that is a code operator. So answer is, that is, which one is the answer? That is the A. Option A is they enhance the portability of the compiler to other target processors. They enhance the portability of the compiler to other target processors. B. The program analysis is more accurate on intermediate code than on machine code. That is, the program analysis is more accurate on intermediate code than machine code. B option. C option is the information from data flow analysis cannot otherwise be used for optimization. That is, information from data flow analysis cannot otherwise be used for optimization. And D is the information from the front end cannot otherwise be used for optimization. Which is the correct answer? Some code optimizations are carried out on the intermediate code because, but here is the two are the answers. But here is the two answers are there in this question. So the first answer is, you see that they enhance the portability of the compiler to other target processors. So, but when you are using the code optimization, definitely it improves the portability. They enhance the portability of the compiler to other target processors. So, for example, you see that if the program size is very small, you can execute on desktop or laptop or any cell phone also. So, second one is the program analysis is more accurate on intermediate code than machine code. But we are so suppose that machine code. So, but we can't find the. So that is error finding. Debugging process is very difficult in the So that is the mission code than intermediate code. So that's why A and B are correct. Both A and B are correct. For the 13th question, A and B are correct. A and B are true for this one. So one is they enhance the portability of the compiler to other target processors, and the second one is the program analysis is more accurate on intermediate code than on mission code. And 14th one, which one of the following is false? Which one of the following is false? A basic block is a sequence of instructions where control enters the sequence at the beginning and exit at the other end. Second one, available expression analysis can be used for common subexpression elimination. Available expression analysis can be used for common subexpression elimination. And live variable analysis can be live variable analysis can be used for dead code elimination. X is equal to 4 into 5, x is equal to 20 is an example of common sub-expression. So that is which one is the false? So that means the first one is correct, right? A basic block is a sequence of instructions where control enters a sequence and at the beginning and exit at the end. So that means this is correct. It is true, but it is not false because already I explained the definition. Second one is available expression analysis can be used for sub-expression elimination. So this is also correct because so whenever the available expressions are there, we can analyze the available expressions and we can eliminate, we can find the sub-expressions and we can eliminate. So B is also correct. And C, live variable analysis can be used for dead code elimination. So that is a live available analysis, live variable analysis can be used for dead code elimination. So this is also correct because at the execution time only we can find either that is a dead code or not. So but the last one we are taking x is equal to 4 into 5, that is equal to x is equal to 20. So it is a false because it is not an example of common sub-expression. Here there is no common sub-expression. But sometimes suppose if you are given that it is a, so that is a constant factory. D will be a constant. So that is the answer is D. Option is D. So for 14th question, the answer is D. And question number 15. One of the purpose of using intermediate code in compilers is to make parsing and semantic analysis simpler, improve error recovery or error reporting, increase the chances of reusing the mission independent code optimizer in other compilers, improve the register allocation. Then which one is the correct answer? 15th. You see that make parsing and semantic analysis is simpler? No, because the parsing and semantics analysis are so performing before the code optimization. That's why it is not related. And improve the error recovery and error reporting. This is optimization is not made for error correction and error recovery rate. And next you see that increase the chances of reusing mission independent code optimizer in other compilers. So the C is the correct answer. And suppose fourth you take that improve the register allocation. So this comes under the code generation. It comes under the code generation, right? So next one is, so answer is for this one, answer is C. And use answer is C we are using. And the 16th question, you see that in the 16th question, consider the following C code segment. For I is equal to 0, I is less than n, I plus plus. For j is equal to 0, j is less than n, j plus plus. If I mod 2, so x is equal to x plus 4 into j plus 5 into I y is equal to 7 into 4 into j and this one. Now you see which one of the following is false for this condition. First A, you see that A, B, A. First you see that A. The code contains loop invariant optimization. The code contains loop invariant computation. Second one is there is a scope of common sub-expression elimination in this code. And C, there is a scope of strength reduction in this code. And D, there is a scope of dead code elimination in this code. Among these four, which one is the false? The code contains loop invariant computation. Yes, here it is a invariant computation. This is true. Why? Because we are taking n, and when you are using this, so I value that we know that it will not be changed. There is a scope of common sub-expression elimination in this code. Yes, this is also correct. But here is that 4 into j, and here is also 4 into j. 2 times the code is repeated. So then it is causes to get sub-expression elimination. And the third one is there is a scope of strength reduction in this code. There is a scope of strength reduction in this code. Yes, there is a strength reduction. So that is so in the previous example we had seen that. So that is a 4 into j. You can write. So T4 is equal to T4 so plus 4. So then here is the scope of strength reduction is also correct. But the last one, there is a scope of dead code elimination in this code. But when you see that within the first statement, there is no dead code. There is a no dead code. All the variables are within the specified loops. So that's why the last one is a false. That is a D is the last 7th question. 17. Code optimization is responsible for what? Application program and all of the possibility of application. Where I explain the thing how to code optimization. The operating system, it is also system programming. So this is also mission dependent. Optimize A, B, C are correct. The code optimization program. Right? So this is the answer is D. So now, so suppose this already I explained this. You see that suppose whenever suppose if you want to write a good program with concerned with time complexity and space complexity, but analysis is control flow analysis and data flow analysis, application code optimizations are very, very important. You see that for this GCD of 2 numbers, I wrote these number of programs. But so when you are using the last program, it can be executed very easily in the even cell phone also. But when you write this program, so that is you see that comparatively time complexity is more. So 23 means the length is very program size is increased, so that automatically so that is it reduce the memory space. So suppose here is we are using that. So next year is also we can use. So that is the second program. It takes only 15 lines. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Only 14 are there, but here is like this is the comment and this is the 2 comments. So we will consider the comments. GCD of 2 numbers, that is the same. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here is 13, but one is removed. So this is the 13 programming line 13, and the code of this one 10. So then this is the 10, and the last one is it contains the 5 lines. So if you want to try it, so you can write entire thing within the only single statement. Either you can write this within a single statement, right? So try for it. Either is it possible to write with a single statement within the main program, right? So that is the int n1, n2, temp, GCD we have taken, and printf, GCD of this one and semicolon. But here is, so all the things within the main you have to write. Only within the for loop you write it. Either it is possible or not, so then you try for it. So if you reduce this to one statement, So definitely we can reduce it. So then it is a more powerful and more compact program. So for this purpose only we are studying code optimization techniques. So that means here is the compiler phase, that is the fifth phase of the compiler phase is the code optimization. Most of the cases we are saying that it is optional, but at the same time in the latest compilers, so that is this is a built-in intermediate code generation. That means intermediate code generation or code generation techniques, it will be sharing the values. So this is the code optimization techniques. Right? I think you understood that. So that is what is the code optimization, what is the importance of the code optimization, what are the techniques I applied, and next how to reduce the program size. Already I explained the GCD of two numbers with 7 variations, and the next one is I explain this because I wrote that program in 7 variations means, so because while you are studying the compiler designs, the analysis, more analysis is required. So we know the more rules and regulations. That's why it is very easy to write more number of programs in any programming languages. Right? So thank you. Thanks for your patience for listening my lecture. Thank you. If you have any queries, you can post it or you give your opinions or your opinion on this lecture. So thank you. Thank you for giving this opportunity. So in the tomorrow's class, I will explain the symbol table. That is also one important topic for GATE. So in the tomorrow, I will explain the symbol table concept. Right. Thank you, Andy. Thank you.